Remind me.
I did say that.
Did you? Oh.
Yeah, and you cheated last too.
All right. A couple of questions for you. Don't want to answer out loud, but think about them. Well, I'll wait for the slide. We're still working. We got some technology we're going to work on. Anticipation is growing. Go back. There we go. All right. Do you have all the information you need readily available to make the informed decisions required to best operate your farm? Do you believe that there might be more useful tools and technology available that you aren't currently using? Do you believe that continuing to farm with the current methods, tools, and technology will allow you to remain competitive and profitable in the next 10 years? About a year ago, a TV show contacted me, had learned about some of the technology and innovation that we were doing on the farm and wanted to do a show on it. And so they came out and the interviewer started asking questions about what we were going to go over, and we were having this discussion. And everything was going great until we got to the robot that we used to move the buckets from the conveyor onto the cooler carts. And he said, due to the network that this program will be airing on, we need to be really sensitive about the displacement of workers, and so how we handle that topic. So I had a very different take on that. First, I recognized that he didn't arrive at the farm on horseback, so there's some technology evolving there too as well. But my take was more of maybe that was a displacement of 1 to 3 employees, but what I was more concerned about was the 140 employees. At the time, that's how many employees we had on the farm. And if we don't take the steps to utilize the available technology and information available, we can easily find that we would be out of business and I would lose those 140 employees. So Henry Ford famously said, if you need a piece of equipment and you don't buy it, you will ultimately end up paying for it, but not having it. And I think that's very applicable. So, you know now that I'm Troy Connor with Kindle Farms, just over the hill there. Most of you, I think, were able to see the farm and a little bit of what we're doing over there. Ken was not bragging about my criminal justice degree. I'm not sure why not. I also grew up in the heavy equipment construction business, ran a heavy equipment construction business for a while, and I was a police officer. So I think we can all agree that I'm ultimately qualified to speak to you today about these farming operations. One thing I do have is a love to learn. I also love to solve problems. The more complicated the problem, the more I enjoy it. So for the last 20 years, I've been applying myself to learning the trade, picking up as much as I can, talking to some amazing people. Many of them are here in the room that have tremendous knowledge about the industry that we're in, and trying to absorb that and apply it to the farm as much as possible. All right, in case I lose you in the next 20 minutes or so, I'm going to give you the 4 takeaways. First, the world's changing rapidly, and it's critical to take advantage of available technology. Second, don't let the fear or challenge of change stop you from securing your future. This is a big one. Often we get very comfortable and we don't want to change, but we have to look at what's up ahead of us and what we can do to make sure that we secure our future. Third is one of my favorite all time. You can't manage what you don't measure. I'm huge on data-driven decisions. Get the empirical data, understand it, and then apply it to make those decisions for your farm. The fourth is very controversial, but I think it's important. Troy is a really interesting guy to talk to, and you might want to buy him a drink. Keep that one in mind. One of my favorites. Okay. most of you did see some of the technology that we're employing over at Kindle Farms. The drone we spray, we use a second drone for multispectral imaging. Plant inventory, we use the ultraviolet light for sterilization. We do pH water control with sulfur burners. We have the remote monitoring and controls of wells, underground water levels, reservoir levels, compost, refrigeration systems, weather, soil moisture, flow meters, valve control, electrical conductivity sensors, nitrogen monitoring, soil oxygen monitoring, geographical information systems, and artificial intelligence. We do not have the time to go through even a portion of that, and that's why we'll just briefly touch on two topics: artificial intelligence and precision irrigation. So, for artificial intelligence, this enables machines to perform tasks that typically require human intelligence, such as learning, reasoning, and decision making. I highly recommend, if you're not already using AI, to dip your toe in that pond, because it's incredibly powerful. And it will give you many, many tools to help you in any of your endeavors, but especially in farming. So, for an example, Sierra, who you might have met at the tour yesterday, she's not only my analyst and assistant, but she's also in charge of the quality control program at the farm. Her and her team take a lot of data points. Every time we have any problems in quality, we're looking at things from the field, the receiving area, and our warehouse processing. And so we have this tremendous amount of data and all these data points. She can take that information, upload that information into our AI, in this case ChatGPT. This is a subscription version, so it has a little bit more power for uploading some files. When she uploads that data, we can ask it to look for the correlations. So we're looking for a correlation coefficient between some of those data points and the quality control issues that we're having. In this case, she's already ahead of me. Look at that, how fast it is. In this case, we're looking for what is the correlation between our botrytis issues and on our wax flower. And you can see here, of those data points there, the highest correlation is with humidity. So this is that time of harvest, that humidity level is the biggest factor for our post-harvest credits. And so having that knowledge, we can look deeper into that. And that was a little bit shocking. We all know about the wet conditions and rain. We don't harvest in rain. We don't want the plants dry, all that stuff. But even the humidity levels have a direct correlation with those credits. And so, is there a graph on there too? I don't know if there is. But yeah, you can see how quickly for somebody, a human, to look through all that, pour through all that data and try to find that correlation is extremely difficult. But with the AI, in seconds, it can calculate that and find, hey, Troy, take a look at your humidity levels and how that correlates with your quality control problems. So, very powerful. Another example of artificial intelligence, how we can use it on the farm, is with the drone. So, we start out with a high-resolution image. We designate the field so we can outline that, isolate that area, and then we upload that image and that data into an AI program that will run its calculations and then try to identify the canopy of each of those plants. And then once it does that, we transfer that over to a geographical information system that can now count the plants within that boundary, and now we have an inventory. This is, again, going back to that one of those fundamental takeaways: you can't manage what you don't measure. One of my biggest things for the last 20 years has always been having the inventory, the plant inventory of each field. And because that's so important, especially with 750 fields to try to keep track of, what kind of attrition rates are we having? What's our death rate on each of those fields? What are the factors going into those attrition rates? And not having that information, it's very hard to manage. You're making guesses. You can see the ones that are, oh, geez, that's really bad. We can look at that, or these are really good, but all that gray area in the middle, extremely difficult to analyze. So tools like this really are helpful. It takes us all year to count the number of plants in the fields. All right, switching over to irrigation. I want to thank Jerry, my assistant, for laying the groundwork on irrigation for me earlier. Appreciate that, Jerry. Who here knows exactly how much water your plants need and exactly when they need it? Irrigation is the single most important piece of management that we can control that lead to the quality, productivity, and health of our plants. So it's extremely important that we know exactly what we're doing when we decide to irrigate and for how long. So all the scientists and PhDs are gonna have to bear with me. I don't often get to show off my criminal justice degree, so I'm going to show you a little bit of knowledge here on water characteristics. Cohesion and adhesion. Cohesion is water molecules clinging to themselves. That's why we have water droplets. Adhesion is those water molecules clinging to another surface, in this case a stem, but for our purposes we're talking about like soil particles. So, capillary force. This is putting those two together. That's a result of the adhesion and cohesion working together to move that water through small pore spaces. And I brought a demonstration for you that you most likely will not be able to see. You put the paper in the water and it starts to draw it up, defying gravity. Well, how is that possible? Well, you just learned adhesion and cohesion working together, and then moving up through that small pore space, and that is how the water can defy gravity and move up in those spaces. So let's talk about soil real briefly. 3 major classifications. You've got your sand, silt, and clay. What we want to take away from this is that the sand is the largest particles and the clay is the smallest. And we want to focus on the larger the particle, the larger the space will be between those particles. And the smaller the particles, the smaller the space. That water, now we're talking about adhesion and cohesion, clings to those particles, and the thicker the layer of that water on that soil or that particle, the easier it is to remove. And so picture a drop of water on your finger. Pretty easy to shake that water droplet off, but there's a film remaining, right? That small film gets harder and harder to remove. The less distance it is from, or the closer it is to the particle, the thinner that layer, the greater that adhesion force, and the harder to remove that, which becomes challenging later for soil tension. So, in this graph you can see on the left, that's saturation. So now we've in those spaces between the particles, we've completely saturated, filled it up beyond the point that adhesion can hold that water in the soil, and so it starts to drain out. Gravity overcomes. Field capacity is now we're finding that equilibrium in between that gravity and adhesion and cohesion, and so now that's the maximum amount of water that soil can hold. As we start to draw that down through the plants or any other means, drying that out, we start to move toward a wilting point. That wilting point is now, like we talked about, that layer of water is now getting so thin on that soil particle that the adhesion is so great, the plant can no longer pull that water from that soil. So, how does the plant function? Starting at the top and the bottom of the leaves, we have the stoma, the stomata. Think of those as the sweat glands, the pores, and so every time a molecule of water leaves the stoma, another one's drawn up. Down at the roots there at the bottom, we have the xylem, flows in, goes up through the xylem all the way out. So you have this removal of the water from the soil. It brings up not only the water, but all the nutrients and minerals as well. Again, down at the bottom in that soil, if there's free water available, we're at field capacity, super easy for that plant to pull that water out of the soil. However, as that dries down, that tension grows, and now that plant is going to struggle to get that water out of the soil, and we're going to start to have stress. Okay. So, how do you measure that? Going back, you can't manage what you don't measure. So, there are several ways to get the empirical data that we need to make those good decisions. I'll group conductivity and volumetric sensors into one group because they're using electronic, basically you're measuring electronic conductivity. So based on either salts or air or soil, how that electricity flows through those mediums, you can measure that, make the calculations, and you can get a measurement that you can use to see how much moisture you have in the soil or available to the plant. There are some issues with that, but it's still a very viable and useful tool. The third category I would put in soil tension. This is a tensiometer. You're familiar with these now. This was what I would call the gold standard for me. It's also what I would call a mechanical root, and I'll go into a little bit more detail how this works. We do fill it with water. This is the ceramic tip, and you can think of when we place this tip at the level that we want to measure, whether it's in wherever in the root zone that we're going to measure, as that soil starts to dry out, the tension grows in that region. It will pull the water through the ceramic tip, and then it will draw it down, creating the vacuum, and that's what gives you the reading on your gauge. So that vacuum, the more tension in the soil, the more water it will draw out, the greater the tension will be, the greater the vacuum gauge will show on that reading. As you re-irrigate, add water back into that soil, now you have the tension or vacuum in this tube. It will draw that water back out of that soil, filling this tube back up, and then it'll drop your vacuum low tension. So you can actually, just like a mechanical root, you can see exactly what your plant is experiencing. And it doesn't necessarily matter how much salt is in the water or to a degree, the particle size and that kind of thing. It's much more accurate as far as what your plant is experiencing. Now, take it to the next level, Aerometer that makes this local company here, been doing it for decades. They have made an electronic version of that tensiometer. This is called the Watermark. And so what we do, I always put in 3 sensors for the plant. And so I go for the top of the root zone, the middle of the root zone, and the bottom of the root zone. And so this for us is 8 inches, 16, and 24 inches. So how do you read all of this and make sense of it? So we need to graph it, and I don't have a laser pointer. I did not grab that. Right here. Is it this guy right here?
Yeah, it's the top button. Top button.
Perfect. Yep, it works. So this blue line right here is the 8-inch sensor. This 16-inch is at this black line, and this 24-inch sensor is down here in the green line. So you can see this 8-inch is very active. A lot of root activity in this zone, and it's pulling and drying out. This got very dry, all the way up to 100. And then you can see here this purple zone in this is we have a pressure sensor in the irrigation line. So when you initiate an irrigation event, that pressurizes that line, we're starting to irrigate. So this is the entire time, starting from left to right, that we irrigated. And you can see that 8-inch fell, then the 16-inch fell, and then the 24 eventually fell as well. And then they start to dry out again as the roots start to pull that moisture out of the soil. This is an underwatering event because you can see how dry that 8-inch sensor got. They've got all the way up to 100. The mechanical tensiometers, they max out at around 80 to 100. It would have broke suction, and then you would have had to restart that whole thing. The electronic sensors, we can go much higher and read that. So moving on to a different scenario. This is where we put sensors in several fields, and then we told the irrigators to go ahead and continue what they're doing, irrigate as they have been, and then we're just going to monitor and try to learn what's going on. You can see here that we have 3 irrigation events right here. The tension's growing, but we're nowhere close to up in our optimal zone here. We're actually very wet, and then we hit the irrigation here, and this one starts to dry out a little bit, getting a little bit closer, but still premature. We could have easily taken out this irrigation event right here with no detrimental effect to the plants at all. All right, so what's a perfect irrigation look like? I don't know. That's hard to say. But this is a good example. So again, we have the 3 sensors. In this case, the 8-inch, the shallow sensor is very high again. The irrigation starts over here. It takes a little bit for that water to reach 8 inches. Then that sensor gets wet and it drops the tension right there. Continue to irrigate, takes a little bit longer, and then it drops to 16-inch. So now we've reached the 16-inch level with moisture in the soil. However, we turn off the irrigation right here. And this is very key that you need to learn at each of your farms where that happens. Because if I continue to irrigate until I reach 24, I'm going to have way too much water. And you see now that I've cut the water right here, there's still a lot of water in that soil column percolating down. So you think of it's coasting now. I took my foot off the gas, but that water is coasting down, and I want to see that water, oops, back it up, sorry, that was me. I want to see that water come down and hit that 24, the bottom of my root zone, and just barely kiss the bottom and bounce back up. That tells me that I got that water all the way to the bottom of my root zone. I didn't over leach my field. I got the salts down to the bottom, but I didn't waste water and I didn't flood it either. So that's what I want to see, where that my deepest tensiometer or sensor just gets reached and then it comes back up. We can go into leaching events and pushing salts and stuff like that, but on a regular basis, this is pretty much what I'm looking for right here. Okay, what does a rain event look like? We just had some rain, not very much, but what's very interesting now is, and it's hard to see on here, but these are rain events right here in these blocks. There's a total of 0.56 inches, 0.3 inches, and 0.61 inches. So the station reads every 1/100th of an inch of rain. It will register that. So not only does it total it for you, but it also shows the rate at which it's falling. And so what's really important here, it's not necessarily how much total rain you got, it's how much effective rain you got. If it all comes down at once and then runs off your property, that's not an effective rain. And so you can see right here, there's a huge spike. So this was a bit of a downpour right here, but otherwise, this is a nice, good rate event here. These 2 slides here, this is the same event, but it's 2 different fields. But what's really interesting here is you can see as that rain event came in here, that's over a 1/2 inch. For Southern California, that's a decent sized rain. It never reached even the 8-inch sensor. Down here, that same 1/2 inch of rain, it not only hit the 8-inch, it went down and hit the 16 and dropped that one. A little bit later on, this is over a 2-day period, this rain event. We have another 1/3 of an inch, and then now this top field here, it did reach the 8-inch sensor. And then over here, not till we reach over 1.5 inches of rain did we finally get to the 16 and the 24. So it's very interesting to learn how your fields respond to your irrigation and your rain events. I can't tell you how many times the irrigation team has said, we got 1/3 of an inch or a 1/4 inch, Troy, we're good to go. Are we? No, not really. So by knowing that, then you can make those decisions. Okay. Going one step further is going into a full automated automation mode. Now that we have the sensors, this system is actually capable of irrigating based on those sensors. So at this 8-inch, this blue aqua line here, that's a start threshold, and this red line here is a stop threshold. So we can schedule an irrigation event or for basically a irrigation schedule for our worst case scenario. And for us, that's August, September-ish, when we have Santa Ana's, long dry periods, hot winds. And so if we build our irrigation schedule for that worst case scenario, we will never underwater. But what keeps us from overwatering would be the sensors. And so say it's Tuesday at 5 o'clock, or in this case, it's closer to 11:30. schedule says it's time to irrigate, it will go and look at this threshold. And if we said we set this up for the 8-inch watermark to say that's our start threshold, it would look and say, in this case, yes, your tensiometer, you're drier than your start threshold, so go ahead and initiate the irrigation. If it was below that line, it would skip that irrigation and wait till the next scheduled event and then try again. So once it does start irrigation, the water will start to flow, and then it will flow until the sensor that you pick, in this case, it was the 16-inch sensor and the stop threshold. So once that 16-inch sensor reached that stop threshold, then shut the valve off at whatever time that was. So worst case scenario, it will go whatever you schedule it for, the longest duration you want, but most often you will hit that stop threshold prior to reaching your time limit. So this is the information that gave us the courage, really, and me the confidence. Last year, we made the decision in part of our year to cut back our irrigation by 30%. I would have never made that decision without this data. I do never have the confidence, so I'd be way too scared to make that kind of a call. But because of having that empirical data, observing what's happening in the field, we were able to make that adjustment. So the benefits of optimizing irrigation: no over or underwatering, higher yields, stress reduction, lower pest and disease susceptibility. Anytime your plants are stressed, they're going to be very susceptible to pest and disease. The water conservation, electricity conservation for us, we're pumping all of that water and moving around, so it's directly tied to that as well. So tons of benefits. Again, that single biggest piece of control that we have on our crops is that when and how long we irrigate. So it's critical that we do that precisely.